second question, it's a little bit complicated. We have given the probability distribution function of the variable y, and we are given that the following transformation: the new random variable x is a function of y given by this equation. So we have x is defined as 1 if the value of the random variable y falls below 3.5, and x is equal to y squared in case y falls above or equal to 3.5. Now we have to make sure and aware that the random variable y, according to the probability distribution function, y takes values between 1 and 4. As you can see, 1 and 4. And it's clear that the PDF or y has no values below 1 or greater than 4. So it's clear that what we need to emphasize that although here y is greater than or equal to 3.5, you need to be careful that this is limited to 4. So this can be written as 3.5 less than or equal to y and less than or equal to 4. This is one of the tricks that many students will not be able to figure out right away. So we need to make sure that we consider always where y is defined. Now, the first thing you need to do when solving such a problem is to sketch the relationship between x and y, or y x. So a quick sketch will show you how this looks like. So we have 3.5 and we have 4. So if y is less than 3.5, x is equal to 1. All right, and if y is between 3.5 and 4, x equal to y squared. So to draw the y square, we know that x equal to y squared so this is x equal to y squared. So we are looking for this point. So first of all, we have to know that this is an open circle, and here we have a closed circle, and this point is 3.5 square, which is 7 over 2 square, which is 49 divided by 4. And this one here is given by 16. Okay, so we have this piece and we have this piece. So now let's find the transformation or the translation of the probabilities. Okay, so first of all, we're trying to find the first question says to find the cumulative distribution function of x. So what's the CDF of x? CDF of x is defined as f capital of x little x, which is defined as the probability that x capital less than equal to little x. So the random variable less than equal to little x. So now we need to look at the values of x. So this is the variable x, and the values of x goes from minus infinity to 16 and beyond. So let's see. So when x, this is very important, when x is less than 1, we see that there is no y mapping. Okay, so we need to find the mapping of the variable x to y so that we can use the density function of y to evaluate the CDF. So this is the event. This is an event, right? So let's write it here. The event x less than equal to little x. Now we can just break this down into multi-events. So first of all, when x is less than 1, so it means that we are here. So the event x capital less than equal to x, there is no y mapping next to it. So it means that this event is the null event. So there is no mapping with respect to y. Now if x is between 1 and 49 over 4, then the only mapping for the event x variable x less than x is just, so this is equal to the event that x equal to 1. All right, so you can see here in the function x equal to 1, which is equivalent to the event y less than 3.5. So this is equivalent to the event y less than 3.5. Now what happens if x is between 49 over 4 and 16? So you can see that the mapping here can be broken down into, so this is the mapping. So so x between 49 over 4 and 16, so x is between 49 over 4 and 16. It's clear that this is the piece that we're looking for. The mapping is, so it's mapped between this point and 3.5. And this point, if this is x, this point is y equal to root x. So if x equal to y squared, then y equal to root x, which is positive root x because it's in the positive side. So this is root x, which means that the probability that x less than equal to small x is given by the probability that y between 3.5 and root x. So the event that 3.5 less than equal to y less than root x union the event y less than 3.5. Okay, so this event is mapped to that event if x is between 49/4 and 16. Okay, so this is the equivalent event. As we can see here, that we have the small part from the y-square curve union the part where x equal to 1, which is y less than 3.5. Okay, and we know that if x is greater than 16, then we have the sample space. So the overall event or the whole event. So now we are ready to take the probability of this. So the probability of this event is equal to, so let's take it one by one. First of all, the probability of the null space, which is equal to 0. So when x is less than 1. And is equal to the probability that y less than 3.5, which is equal to, how do we find this? We found this from the distribution function, probability distribution function. So 3.5 is here. The probability that y is less than 3.5 is basically the integral from minus infinity to 3.5 of the PDF, which is, in other words, the area under the PDF y from minus infinity to 3.5. And this area is decomposed into two areas. This area first, which is half the area of the rectangle. So the area here is half times the area of the rectangle, which is 3.5 minus 3, which is 1/2 times the height. So 1/2 times the height. Okay. Sorry. 1/2 times the area, which is the area of the full rectangle, which is 4 minus 3, 1. 1 times the height, which is 2/3. And the answer is 1/3. Plus the area under this delta function. And the area under this delta function is just equal to also 1/3. Okay, which is basically the area from minus infinity to 3.5 of 1/3 delta y minus 1 dy, which is equal to 1/3. So this is 1/3 plus 1/3, so the total area is 2/3. So here this is equal to 2/3 when x is between 1 and 49/4. Now the other one is for x between 49/4 less than x less than equal less than 16. So the probability in this case is equal to the probability that y less than 3.5 plus the probability that y is between 3.5 less than equal to capital Y less than root x. And we already know this, which is 2/3 plus the integral of the PDF from 3.5 to root x of fy little y dy. And since x is between 49/4 to 16, then this interval is between 3.5 to root 16, which is root 4. So this interval is always a subset of 3.5 to 4. So which means that we are always falling into this interval here, and in this interval the PDF is equal to 2/3. So this is equal to 2/3 for all x between 3.5 to 4. So this equal to 2/3 plus 2/3 integral from 3.5 to root x dy. So in this case we have 2/3, take it as a factor, this will be 1 plus root x minus 3.5. So the answer is, final answer, 2/3 root x minus 2.5, which is 5/2. So now we have this answer. So 2/3 times root x minus 5/2. And finally, when x is greater than or equal to 16, it's clear that this is the probability of the sample space, which is equal to 1. So recap, in this case the cumulative distribution function is equal to 0 for x less than 1, 2/3 for 1 less than equal to x less than 49/4, and then 2/3 root x minus 5/2 for x between 49/4 less than equal to x less than 16, and 1 for x greater than equal to 16. So part 2, calculate the probability density function of x, which is simply the derivative of the CDF of x. And here we have to be careful because this function may not be continuous for all x. So let's check. If we sketch the distribution function, the cumulative distribution function, we see that we have these intervals 1, and we have 49/4, and we have 16. So that's x, that's the F capital, which is the CDF. So we have first the value 0, from -infinity to 1, and this is an opened circle. And then from 1 to 49/4, we have a jump. So this is 2/3. Of course, this is the maximum one. So if this is 1, so we can say that that's half. That's 2/3. Okay, 1/3. So in this case, we have this closed at 1. It's 2/3 up to 49/4, so it's open. And then from 49/4 to 16, we have a square root function. So as you can see, if you evaluate this function at 49/4, is equal to 2/3 root 49/4, 7/2 minus 5/2, and that's give me 2/3 times 2/2, which is equal to 2/3. So at 49/4, we have the value is 2/3, so this is closed. So there's a continuity here. And we know that at 16, this is equal to 2/3 root 16 minus 5/2. So that's equal to 2/3 4 minus 5/2, which is 1/3 8 minus 5, which is 3/3 equal to 1. So there's a continuity at 16. So at 16 is 1. And it's just 1 for greater than 16. And there is the square root curve, which is given by this. Okay, so now we can see that we can take the derivative of this function easily, but be careful, there's a gap here, and this gap is a unit step, or basically a step function of a gap of length 2/3. So the gap length is 2/3. When you take the derivative, okay, so the derivative is equal to 2/3 delta, and it's placed at 1, delta x minus 1. Okay, the derivative here, d by dx of this function equal to 0. D by dx of this function is equal to 0. D by dx of this function is equal to 2/3 times 1/2 root x. So 2/3 times 1/2 root x, which is 1/3 root x. And the derivative here is equal to 0. So now we can see that the density function of x, little x, equal to 2/3 delta x minus 1 plus 1/3 root x for x between 49/4 less than x less than 16 and 0 otherwise. And that's it.